So now we're going to talk about the Monty Hall problem because it's relevant to the idea of restructuring. Okay, so here's the Monty Hall problem. All right, it comes from a show from the 60s or 70s, and what and where Monty Hall, the host of the show, would show you three doors. And you're a contestant. If you're a contestant, you have to pick one of the three doors. And behind one of those three doors, there's a car, which obviously you want. And then behind the other two doors, there are goats. And the idea is that you don't want a goat. But in this scenario, you don't know where the car is. All right. So let's say you go with door one. Let's say, right? Well, what happens is Monty will go, "Hey, I'm going to open one of these doors and show you that there's a goat behind it." Right? And so the question is, would you like to change your answer? Right? Would you like to change from door one to door three? Or would you like to stay at door one? Which one? And the thing that one important detail that you should remember is that Monty, or the person who opens the door, is not randomly picking any of the two doors. The person opening the door knows that they're opening the door to a goat, and that's really important. So to keep that in mind, okay? And if you're like most people, you will say that it doesn't matter whether you switch to door three or you stay at door one. Most people assume that there's a 50-50 chance that the car is behind one of the other doors. However, they're wrong, right? The correct answer is that you should switch. I'm going to demonstrate that in a second. But if it's not clear, just know that there's a lot of videos on this. So I'm going to do my best to explain it. And also, I'm going to try to hopefully explain it in a way that makes it more obvious as well when I restructure it. Okay. So yeah, this problem actually stumped a bunch of well-educated men and even a mathematician. And this lady right here, you probably can't see her in the right-hand corner. Her name is Marilyn Voss Savant, and she has an obscenely high IQ, right? She scored a very, very high IQ score. Okay. And so she has a weekly column called Ask Marilyn. And she gave the correct answer. She said you should switch. And in response, she received a lot of hate mail from people. And so, in response to that, she published her reasoning. And here's the reasoning, okay? So Matt, here let's these are all the possibilities. So you have a car, one game you have a car behind door 1 and then a goat behind door 2 and 3. In game two, you have the car behind game door two, and then you have goats behind door one and three. And then in game three, you have a car behind door three and goats behind door one and door two. So these are all the possible games that you can play. Okay. And so let's imagine you said door one. Okay. Now, it doesn't matter whether you say door one, door two, or door three. Okay. The logic applies no matter what. So just know that. Okay. So what happens is if you were to say door one, right? And then what happens is Monty would open door two to show you that there's a goat. So now you only have door one and door three. So if you switch to door three, you're going to get a goat. And so you're going to lose, right? And then if the car's behind door two and you say door one is your original choice, well, what happens is Monty's going to open door three, let's say. And then the question is, do you switch? If you switch to door two from door one, you'll win. But if you stay, you'll lose, right? If the car's behind door three and you say door one, and then you switch, right? Because again, the goat door is going to be out of the play. Door two is going to get opened. And so then if you switch to uh, door three, you're going to win. Okay. So this tells us that the probability of winning if you switch is 2/3, so 66%, right? Now let's do the same thing. Let's do the same thing, but now let's see what would happen if you stayed. Okay. So let's imagine again, these are all the possible permutations in which goats and cars can be behind doors. Okay. So if you said door one and then you stayed after door two was out of the mix, right? It was opened, then you'll win, right? However, if you said door one and then Monty opened door three and then you stayed at door one, you would lose. And then again, if you stayed at door one when the car is behind door three, you'll also lose. Okay. And so this shows that the probability of winning if you stay is actually one third. And you might be asking, okay, how did she solve this so easily? Maybe, hopefully, the logic makes sense, right? I demonstrated to you why it's better to switch. You have a higher probability of getting the car if you switch. But she solved this really easily. And so she actually describes her thought process in the column. And, to foreshadow it, this is basically what restructuring is. She's restructured the problem and made the problem much easier to solve. So instead of having three doors, she said, well, imagine there's 100 doors. Okay. You have 100 doors. And let's say if you picked one door, let's say door one, there's a 1 out of 100 chance that you picked the correct door. And then the probability that winning given any of the other doors is cumulatively 99 out of 100. Okay. And so if you pick door one, right? And then just like in the Monty Hall problem, the original Monty Hall problem, well, what's going to happen? Monty's going to open up 98 doors that have goats behind them, right? And so now the question is, does your original door have the goat behind it? If so, well, there's a 1 out of 100 chance. But now the probability of 99 out of 100 has shifted from all of these doors to this one door. So now the probability of winning if you switch is actually 99 out of 100, right? Um, so yeah. So how did she represent? So this, hopefully it's clear that by representing the problem differently, the solution becomes obvious. And again, Gestalt psychologists call this restructuring, which is when the problem is represented differently than how it is presented. And they believe that restructuring leads to noticing a crucial element that suddenly leads to a solution. Okay, in the next video, we'll talk about the candle problem, and that'll be it.